In this video, I introduce a training GAN using semi-supervised learning. It's very hard to train GAN using a minimum maximum way to find a Nash equilibrium. Here, we use semi-supervised learning to effectively train the GAN models. Consider a classifier to classify data X into one of k possible classes from L1 to Lk. The class probabilities are computed via the softmax function, which is a normalized probability distribution over classes. In supervised learning, a model is trained by minimizing the cross entropy between the observed labels and the model predictive distribution P. Semi-supervised learning adds samples generated by the GAN generator G to the training dataset, which are labeled with new plus k plus 1. And therefore, the number of classes increases from k to k plus 1. The conditional probability of k plus 1 provides the probability that X is fake. We can learn from unlabeled data as long as we know that it corresponds to one of the k classes of real data by maximizing log conditional probability. Given a standard classifier, we use supervised learning to train this classifier to predict the classes of the input data. And then we add samples generated by generator into training dataset and add one more class in the class list. If we know the label for sample is one of the classes from L1 to Lk, we can use the conditional probability of k plus 1 to predict the probability of X being fake. And then we use this model to train the GAN models using unsupervised learning. First, generator G maps the noise vector Z into a new distribution X. And then we use X as the input to the discriminator to predict the probability of X being fake by minimizing this loss function, namely maximizing this conditional probability of k plus 1. And then we use unsupervised loss to improve the generator to generate a better X until this unsupervised loss is smaller than specified criteria. And then we jointly train the classifier by using the supervised learning and train this part in the unsupervised learning. Formally, suppose that half of the dataset consists of real data and half of it is generated. The loss function for training the classifier includes two parts. One is the supervised loss, one is the unsupervised loss. In this way, total cross entropy is decomposed into supervised loss and unsupervised loss. We find the optimal solution to a GAN model by minimizing these two loss functions jointly. For more details, please check with these references. Thank you. Bye.